All right, let's do Unit 4, Lesson 3, which is linear function operations. So we can actually perform arithmetic operations on functions like adding, subtracting, multiplying, and dividing. So all of our answers to match, all answers should be simplified or reduced when possible. So when you add functions, there's two different notations that you might see. So you might see like g of x plus f of x, or you might also see it written as g plus f of x. So first thing, those mean the same thing. It's just two different notations, and we're going to interchange them so you get used to both. But when you add functions, you want to combine like terms. All right. So for subtracting functions, same thing. You'll see it written as g of x minus f of x, or you might see g minus f of x. And when you subtract, you want to use parentheses on the second function. And so that will ensure that you're going to be distributing a negative to all the terms for the second function. Okay? All right, multiplying functions, it can be written as g of x times f of x, or g times f of x. And when you multiply, you're going to distribute or double distribute, which is FOIL, and then combine like terms. So for dividing functions, and you might see it written as, we can use the symbol or the division symbol, either way. And when you divide, this one is a little tricky, but you want to reduce all terms. So if they reduce by 2, it's by all the terms, not just one or two of them. All right, so let's practice. So on our first example, we're going to name G and H, and the instructions tell you to add them together. So I'm going to take n plus 3, that's G, and I'm going to add H. When you add, you don't need any parentheses. It won't make any difference. But we want to combine like terms. So I've got 1n plus 4n, and then positive 3 minus 3 is 0. So you can write it or you don't have to, but this would be my final answer. All right, let's do the next one. So h minus g. So subtraction, we need to use a parenthesis. So I've got h. We don't need the parenthesis on the first function. Minus, I need to subtract everything that is in g. So when you subtract, it's like a -1, and that's what we're going to distribute to both terms. So 4x plus 4, -1 times 2, and then -1 times -5. This is the term that's missed the most with the sign. So combine like terms. We've got 4x minus 2x, which is 2x, and then 4 plus 5. All right, let's look at the third one. We're going to multiply. So when I multiply, I see that they both have two terms, so I'm going to use parentheses around both functions. So h and g. Now, this is double distributing, so you're going to take the 2n and you're going to multiply it by both terms in the second function. So 2n times 2n is 4n squared, 2n times 3, and then I have to take a -5 and distribute to both terms. So -5 times 2n, -5 times 3. And then we're going to combine like terms. So our final answer is 4n squared minus 4n minus 15. Even though these both have n's, they're different powers, so you cannot combine them. All right, let's look at our fourth, g times f. So they both have one term, so I can write g times f. So this is like a -1, and both of these are to the first power. So I've got 4 times -1, and then when the variables are the same, you add exponents. So 1 plus 1 is 2. All right, I've got f divided by g. So f comes first, it needs to go in the numerator. And g. Now, because these have a plus and a minus, I can't do any canceling of the t's. It has to be by all terms. And 3 and 4 don't have anything in common, so this is your final answer. There's nothing that can be simplified. Let's try our next one. We've got g divided by h. Okay, so I've got 1, 2, 3 terms. So I know all of those terms can reduce, which means to divide all terms by 2. So I divide this by 2, I divide this by 2, and this by 2. That's what I mean by all terms. So our final answer is going to be 2t minus 1 all over 2. And that's a great answer. Some answer keys might split it up because there's one term on top. So if you want to compare it, you're going to have to write it separately. You've got 2t over 2 minus the 1 over the 2. Well, those reduce, so I'd get t minus 1/2. So both of these are good answers, and they're fully correct. It's not like one is more simplified than the other. So be flexible. All right, the next section is about function operations with a value. So when you see this problem, you have 2 different options. What that actually means is you want to do h plus g, simplify, and then I want to know when your variable is equal to 10. Okay, so your other option, so that's option number 1, is I can do h and substitute 10, and I can add g and substitute 10. They'll both give you the same answer, but they're different strategies. So same thing. Here, that means I can also do g minus h first, and then I can substitute x equals 3. Or I could do them separately. Substitute, find g of x when x equals 3, and we subtract, find h of x when x equals 3. Okay, so this is going to be the same idea. I can also do f minus g when x equals 4, or I could do f of 4, substituting, and I could take off g of 4 and then subtract. So let's go through some examples. So I can show you both ways. So on here I've got g minus f. So here's g minus, remember with subtraction you always want to use parentheses. Okay, so I can distribute the negative. And then I want to just plug in a. So a is already my variable, so all I need to do is combine like terms. You can put these in any order. The answer key will usually be written with the highest power first. And then -3 and -5 is -8. Okay, your options really come when they give you a value for substitution. So g times h of 1. So I've got g. And you might want to evaluate this on a problem-by-problem basis to see which one do you think is going to be faster. So that's g times h. Now, I could distribute. It's going to be a lot of work, but because I'm given a function value, I don't need to simplify the function. I just need to know what it is when I substitute n equals 1. So everywhere I see an n, I'm going to put a 1. And so you can type this into a calculator. So I've got 1 squared plus 4 plus 2 times 1, which is 7. And then we've got -3 times 1 plus 2. So then 7 times -1 is -7. So you don't need the expression, you just need the numerical answer. And you could have typed all of this into a calculator at one point if you have access to one. All right, let's look at our last example. We've got h plus g of 10. So here's h plus g. I can combine like terms. And then I want to know when x equals 10. So we can substitute. So we get -10 plus 4, which is -6. Now your other option is if I did, here's h plus g, and then I could substitute 10 in here. So 30 plus 3, -4 times 10 plus 1, and then I add them together. So you can see the answers are the same and the strategies are different. So if you struggle with combining like terms, go ahead and immediately substitute and simplify.